Imagine a space station designed not just for science, but also for military operations. In the heart of the Cold War, secrecy was paramount. The Soviets launched a series of orbital platforms that blurred the line between research and defense. These stations operated in silence, unseen by the world below. One of the most ambitious of these projects was Almaz. Almaz was intended to test human survival in orbit while secretly supporting reconnaissance missions. Crews would live and work in space for weeks at a time. Cameras and sensors monitored the Earth with unprecedented detail. It represented a leap in both technology and ambition. Few people outside the Soviet space program even knew it existed. The Almaz program began in the early 1960s. It was developed by the Soviet Union as a response to the U.S. military space initiatives. Initially, the project focused on crewed reconnaissance and weapons testing. Engineers envisioned a station that could both observe and, if necessary, defend itself. This dual-purpose mission defined every aspect of its design. Designers converted military requirements into orbital hardware. The stations were equipped with reinforced hulls to protect against micrometeoroids. Observation ports were optimized for high-resolution imaging. Life support systems were enhanced for longer stays. Even the interior layout prioritized operational efficiency over comfort. Almaz was part of a larger plan for a Soviet military space presence. It was intended to complement ground-based intelligence systems. Reconnaissance satellites could capture broad data, but humans provided adaptability. Crew members could adjust observations in real time. The station became a symbol of both innovation and strategic ambition. Only a small number of stations were built. Limited production reflected both cost and secrecy. Engineers focused on quality over quantity. Each station was a testbed for new technology. The crewed missions were carefully planned to maximize scientific and military data. Early prototypes underwent extensive testing on Earth. Pressure chambers and orbital mock-ups simulated long-duration missions. Engineers studied crew fatigue, equipment reliability, and radiation protection. These lessons informed both the Almaz stations and later Soviet space programs. Safety was a critical concern given the station's military role. Almaz merged existing space technologies with new innovations. Orbital maneuvering systems allowed flexible positioning. Advanced life support extended crew endurance. Cameras and reconnaissance tools pushed sensor technology. Every system was designed for dual-use capability. The result was a station unlike anything previously in orbit. Almaz stations were built to support three-person crews. Living quarters were compact but functional. Workstations were equipped for scientific and reconnaissance tasks. Every cubic meter was optimized for efficiency. Redundant systems ensured survival in case of failure. The stations carried high-resolution cameras for Earth observation. Imaging technology was top secret and unmatched at the time. Sensors could monitor military installations and industrial complexes. Data was transmitted to ground stations in near real time. The stations combined human judgment with technological precision. Life support included oxygen generation and carbon dioxide scrubbing. Waste recycling systems were basic but reliable. Thermal control maintained stable conditions. Radiation shielding protected crew members from solar and cosmic rays. These systems allowed missions lasting several weeks in orbit. Almaz included a small docking port for resupply and crew exchange. Soyuz spacecraft were used to deliver personnel and materials. Docking procedures required extreme precision at orbital speeds. Crews trained extensively on Earth before attempting these operations. Safe docking was critical to mission success. Power came from large solar arrays. These supplied electricity to all systems on board. Batteries provided backup during orbital night. power management was crucial for sensors and life support. Engineers designed the station to survive extended periods without resupply. Some stations were equipped with defensive capabilities. A small cannon was reportedly tested on at least one mission. Its purpose was both deterrent and experimental. Weapon operation required careful coordination with ground control. This militarized aspect made Almaz unique in space history. Almaz's orbital performance was impressive. Stations could maneuver to optimal observation positions. Attitude control was precise for camera alignment. They remained stable despite minor orbital perturbations. Engineers continuously improved control systems over successive missions. The stations proved long-term human habitation in orbit was feasible. Almaz stations were launched into low Earth orbit to conduct secret reconnaissance missions. Crews conducted observations over strategic targets using high-resolution cameras. Daily routines combined maintenance, data collection, and scientific experiments. Flight schedules were strictly planned to maximize observational coverage. Ground teams guided the stations remotely to optimize positioning. Each mission tested both human endurance and system reliability. The first operational flights focused on validating the station's life support systems. Crews monitored oxygen levels, CO2 scrubbing, and temperature regulation. Engineers closely analyzed crew performance during orbital maneuvers. Observations informed modifications to systems and equipment. Every flight improved the efficiency of subsequent missions. Lessons learned were shared with later Soviet space programs. Almaz also conducted experiments in microgravity. Crew members tested material behavior in zero-G. Biological studies examined human adaptation to long-duration spaceflight. Small laboratories on board allowed a wide range of experiments. Data from these studies contributed to both military and scientific knowledge. The stations served as valuable testbeds for extended space missions. Docking and resupply were critical for operational success. Soyuz spacecraft delivered new crews and essential supplies. Docking procedures required precision at high orbital velocities. Crews trained extensively on Earth simulators. Any mistake could endanger both the station and the mission. Operational success depended on both skill and engineering. The onboard observation systems were state-of-the-art. Cameras could capture detailed imagery of Earth below. Infrared and other sensors enhanced reconnaissance capabilities. Data transmission required secure and reliable communication links. Engineers monitored performance continuously from ground stations. The combination of human oversight and technology was unmatched at the time. Missions were carefully coordinated with other Soviet space assets. Reconnaissance satellites complemented Almaz observations. The station could focus on areas requiring detailed analysis. Crew decisions added flexibility not possible with automated satellites. These missions proved the advantages of human-in-the-loop reconnaissance. Almaz demonstrated that crewed stations could serve strategic purposes effectively. Despite the operational success, risks were always present. Micrometeoroid impacts and radiation exposure posed constant threats. Mechanical failures were rare but serious when they occurred. Crews had to maintain vigilance at all times. The operational history of Almaz reflects both innovation and courage. The program established benchmarks for crewed military space stations. Almaz stations featured reinforced hulls to withstand micrometeoroid impacts. The structure was heavily armored compared to civilian stations. Windows and observation ports were small but strategically placed. Life support systems were advanced for the 1970s. Thermal control systems maintained stable internal conditions. Redundant systems ensured crew safety in emergencies. Power was supplied by large solar arrays with battery backup. Engineers optimized energy distribution for sensors, life support, and communication. The arrays could be angled to maximize sunlight absorption. Batteries ensured operations during orbital night. Power management was a critical element of mission planning. Every system was designed for efficiency and reliability. The station included sophisticated orbital maneuvering capabilities. Thrusters allowed precise positioning for observation and docking. Crews practiced frequent adjustments to optimize data collection. Orbital control extended the station's operational lifespan. Engineers monitored fuel usage carefully. Maneuvering systems were tested extensively before each mission. Observation equipment was state-of-the-art. High-resolution cameras captured detailed imagery for both scientific and military purposes. Infrared sensors enhanced night and low-light observation. Data was stored and transmitted securely to ground stations. This combination of hardware enabled unprecedented Earth observation. The technology set a standard for subsequent space stations. Communication systems were highly advanced for the era. Secure channels ensured that sensitive reconnaissance data could be sent without interception. Redundant transmitters provided backup in case of failure. Ground teams could provide real-time instructions to the crew. Reliable communication was essential for both safety and mission success. The system allowed for coordinated operations with other space assets. Onboard laboratories supported scientific experiments. Crew members studied microgravity effects on materials and biology. Experiments ranged from fluid dynamics to plant growth. Data collected informed both military and civilian space projects. The combination of military objectives and scientific research made Almaz unique. The station functioned as both a lab and an intelligence platform. Defensive innovations were also included. Reports suggest at least one station tested a small cannon for deterrence purposes. The weapon was designed for precision and limited use. Training ensured crews could operate it without jeopardizing the station. This militarized aspect made Almaz unlike any other space station. The technological innovations demonstrated both ambition and adaptability. The Almaz program left a lasting impact on space technology. It demonstrated that crewed military stations were feasible. Life support, orbital maneuvering, and observation systems set new benchmarks. Lessons learned were applied to later Soviet and Russian space stations. The dual-use approach influenced future reconnaissance and research designs. Its legacy persists in both military and civilian aerospace programs. Almaz's crewed reconnaissance missions proved humans could operate effectively in space for extended periods. This experience informed cosmonaut training and mission planning. Observational techniques developed on Almaz were applied to both satellites and later stations. Data transmission and secure communications protocols became standards. The program highlighted the value of human-in-the-loop intelligence. Its contributions were crucial for Cold War strategy. The technology tested on Almaz inspired subsequent space station designs. Reinforced hulls and modular systems influenced Salyut and Mir stations. Life support advancements carried over to long-duration missions. Observation and sensor systems improved Earth monitoring. The lessons helped refine orbital construction and maintenance procedures. Engineers leveraged these insights for both military and civilian platforms. Almaz became a blueprint for adaptable orbital infrastructure. The dual-purpose concept combined scientific research with strategic intelligence. It proved that a single station could fulfill multiple objectives. Crews collected scientific data while simultaneously conducting reconnaissance. This approach increased efficiency and mission value. It demonstrated a new paradigm for space operations. Future programs adopted this integrated model. Almaz validated the feasibility of multi-role orbital platforms. The program also emphasized the importance of secrecy in space operations. Classified missions ensured technology remained ahead of potential adversaries. Ground control protocols balanced operational security with safety. Crew selection and training were rigorous and specialized. The program's covert nature added to its mystique and strategic value. Almaz became a symbol of Cold War ingenuity. Its operations influenced later intelligence-gathering satellites. Almaz paved the way for international space station development. Modular design concepts were refined over decades. Long-duration human habitation research contributed to Mir and ISS. Sensor and observation technology advanced orbital surveillance capabilities. The program demonstrated how strategic and scientific goals could coexist. Its pioneering work provided a foundation for global space cooperation. Engineers continue to study Almaz for lessons in station design. Today, the Almaz stations remain a testament to ambition and innovation. They proved that humans could perform complex operations in orbit under extreme conditions. The program's secrecy and technological achievements continue to fascinate historians. Its dual-purpose mission foreshadowed the blending of scientific and military space projects. Even decades later, Almaz inspires engineers and aerospace enthusiasts alike. Its legacy in orbital technology and Cold War history is secure.